Hello everyone. The topic of this video is Introduction to Programming, also known as Creative Problem Solving. Okay, so programming essentially is problem solving. So of course, when you learn a programming language, first you learn the syntax of the language, the various rules, the grammar, etc. But that is the easy part and the beginning part. But what you need to graduate to, what you need to progress toward is to actually use those techniques and combine them to be able to solve problems, to look at a problem, break it down and use these techniques to somehow solve it. Okay, so if you're able to master programming, you can use this skill to actually apply in various different domains to solve problems. Also, even though this is a course which has artificial intelligence and other topics, the most important skill that you need to bring into this course is the skill of programming. Okay, the other skills of learning the actual subject are in fact less important than this essential base skill of programming which you really need to master. Okay, next let us look at programming languages briefly. So programming languages come in two flavors. Okay, one is high level languages and the next is low level languages. So what are high level languages? High level languages are essentially languages which are easier for humans to write. They are like C, C++, Python, Ruby, etc. So it is easier for humans to write and read and understand, whereas for a computer to understand these languages, you have to do some more processing and intermediate. You have to run this code through a lot of intermediate translation steps to convert it into a form in which the machine can understand. Okay, so you know that computers essentially work directly with zeros and ones, right? So but for humans, if you look at a string of zeros and ones, you cannot directly make sense of it. So what we do is we write in a high level language and then we convert it into those strings of zeros and ones. So the next thing is low level languages. So assembly language or machine language. So these are examples of low level languages. So these low level languages are written in uh, using some vocabulary which is very close to what the machine actually does. Okay, so the machine has a native vocabulary. So the machine does some primitive operations on zeros and ones, right? So these low level languages, they speak only in that vocabulary. So it is easy to translate from a low level language directly to machine language, whereas in high level languages we have abstractions and we have vocabulary which uh, is directly not present in the vocabulary of the machine. We have to translate it into that vocabulary. So what are the benefits of higher level languages? So high level language code is shorter and it is easier to read. Okay, that is the most important benefit. So the longer that your program is, the greater the chance is that you make a mistake somewhere. So one thing that you must understand is that even if you have a computer to function properly, you have to precisely tell it exactly what it needs to do. If your instruction is off even by little bit, it can create a great catastrophe in the output of the result. Okay, so now the longer that your program is, the more because humans are naturally error prone, the more chance there is that you make a mistake somewhere. So in high level languages, we get the opportunity to express a big idea using a small amount of code. Okay, so that makes it shorter and easier to read and also less error prone. But what is the benefit of low level languages? So because the low level languages directly speak the vocabulary of the underlying machine, so if you want to make certain optimizations or improve the efficiency to the last bit, so in those cases where performance is of extreme value, sometimes you need to drop down into low level languages to make some tweaks to get that, to extract that performance. Okay, but we are in an age when there is, like, the computing speeds are increasing more and more every day. So this is less of a concern than it used to be, say 20 to 30 years before, when computing was a scarce resource. But today's computing is an abundant resource, so that is why mostly you will see that people don't work in low level languages and people prefer to work in high level languages. Okay, so in this course, Python is one of the languages that we'll be focusing on, and Python is naturally a high level language. Another distinction that you need to be aware of is interpreted versus compiled languages. So interpreted languages are those languages in which there is an language interpreter which processes the program line by line and then performs some computation. Okay, so examples of this are Python, PHP, Ruby, etc. And another class of languages is called compiled languages. So in compiled languages, what happens is you write your program, the whole program is then processed using a compiler, and this compiler translates that high level source code into low level object code, or it is also called an executable that is run by an executor. Okay, so you can think of it in this way, that it translates it from a high level language into a low level language, and then you run that whole code in that low level language at once. Okay, so that is the major difference between interpreted and compiled languages. So C, Java and Haskell, these are some examples of compiled languages, whereas Python, which we will be using, that is an interpreted language. So the next thing that we are going to look at is interactive mode versus script mode. So what is the interactive mode? So Python, when you install it on your machine, it comes with something called as the Python interpreter. Okay, so how to open this Python interpreter? Just type Python 3 from your terminal. So now in this you can directly type in Python code and the interpreter will execute them. Okay, there was a mistake here. And you can see that I asked it to print this string hello world and it has just printed it. Okay, so this is called the interactive method of programming, where you just type in some code and look at the output of how it is behaving. Okay, so that is the interactive mode. There is another mode called as a script mode, where you actually open a file. So let me say vi temp.py. So Python files should always have this file extension of .py. So I've opened a text editor and now I'm going to just write some Python code and print training program. So these two statements I have written in my Python file. I'll save it and now I can run it using a command like this, Python 3 and then the name of the file. So you can see that it has executed these two commands, hello world and welcome to this training program. So these are the two different ways in which you can actually program. One is using the in the interactive mode, in which you use the Python interpreter, and another is the script mode, in which you write a piece of code and then you execute it all at once. Okay, so interactive mode is useful for when you're experimenting, when you're running small experiments with your code and you're still trying to understand the problem. So that is when interactive mode is helpful. But when you're actually going to build a large system or going to write a large piece of code, then you must use the script mode. Okay, but in this program mostly we'll be using something called as Jupyter notebooks. Okay, so as already explained previously, Colab is the platform that we are going to be using. So the benefit of this is that this has the advantages of both interpreted and the script mode. Okay, so when you're experimenting with your program, or when you're still playing around with it, you can use the you can use the interpreted mode, because within these cells you can directly run code. Okay, just let it connect. So here I can say print hello world and I can run it immediately and see what is the result. Okay, now I can add to this. and I can run these both together and see what is the result. Now I can just export this into a .py file. So I have the script. So the benefit of this is that you can program using the interactive mode, but at the end you will also have a script that you can simply save uh, and reuse later. Okay, so that is the benefit of Jupyter notebooks, that let us use interactive mode and the script mode simultaneously. The next thing that we're going to look at is debugging. Okay, so for some strange historical reasons, programming errors are called as bugs. Okay, so this is a term you will hear a lot as you go down your programming journey. So you'll hear this statement like there was a bug in the program, or like I'm unable to find out what is the source of the bug. You'll hear programmers often complaining about this. So what are bugs? Bugs are nothing but some programming errors due to which the output that you're expecting after the execution of the program is not the same as what the uh, program is actually giving. Okay, so you have an expected output and there is the actual output. They are not matching. That is because of some bug in the code that you have written. So you have to go and track it down. So tracking them down and fixing them, this is called as debugging. Okay, so most of the time when you program, you will actually spend debugging. So at least 50% of the time. So you may actually write the program and then you'll go back and try to see like why it is not functioning exactly as you intended it to. So what are these bugs? So these bugs are basically, they can be of three types: bugs or errors. So one is syntax errors, runtime errors, and semantic errors. So let us briefly look at them because you're going to encounter them a lot. So first is the syntax error. So as a beginner, beginning in a programming language, so syntax errors will be your first major enemy. Okay, so you'll spend a lot of time tracking down these syntax errors, but these are the most trivial kind of errors or the easiest to fix. So this error appears before the program starts running. So most of the time Python will not even execute the code before it throws a syntax error. Like even if your program is slightly off, for example, let me give you an example. So let me show you an example. So if I say print hello world, but I don't include this second quotation. Now if I try to run this, so you see that there is a syntax error, EOL while scanning string literal. So this error is because I forgot to include this, close the quotation. If I close it and run, then there is no error. So difference in a single character, if you miss a single character, this can throw an error. So another example is, so earlier we saw that we didn't have a matching quotation mark. So that was the error. Another common error is when you don't have a matching parenthesis. So for example, if you do 1 plus 2 and include parentheses on both sides, that is legal and that will work without any error. Whereas if you only include the right parenthesis in the, like as in this case, then this is not legal and this will throw a syntax error. Next is runtime errors. So what are runtime errors? So this type of error does not appear until after the program has started running. Okay, so your program, initially there will be no complaint. The program will run the code for a certain amount of time, and later during its runtime, in between, it will throw this error. Okay, so let me show you an example of a runtime error. So division by zero error is a common runtime error. So in this simple program, what I'm trying to do is I'm starting with x equal to 3 and I'm writing a loop in which in each iteration of the loop, I reduce my number by 1 and I try to print what is 1 divided by that number. Okay. Now if I run this, you see that there is a zero division error. Okay, so why this is happening? Because I reduce x by 1 each time, so 3 2 1 and then it goes to 0. So but this error was encountered after the program actually ran and printed these statements. So after partially running the program, then the program ran into this zero division error. So this is an example of a runtime error. Okay, so these errors are also called as exceptions, because they indicate that something exceptional or bad has happened. So later in the training, you will also learn about how to handle these exceptions. So sometimes you can anticipate that some kinds of exceptions are likely to occur and you can handle them. So these are called as runtime errors. So the last kind of errors that you'll have to deal with are semantic errors. Okay, so syntax error, we looked at syntax errors and runtime errors. So syntax errors are the easiest to fix. They will appear even before your program starts running, and you just have to fix the syntax. Next is runtime errors. These are little more difficult to fix. You have to track down what is the source of this error. Some other computation performed earlier or in some other place may actually be responsible for it. The hardest to fix are the semantic errors. Okay, so in these kinds of errors, the program will actually run without any error, but it will not do the right thing. It will not give the output which you're expecting. That means the semantics or the meaning of the program that you have written is actually different from what you intend it to be. Okay, so to fix the semantic errors, so you'll have to use a lot of print statements and other debugging techniques to track down where actually the program flow is deviating from what you want it to be and fix it at that place so that the semantic error is resolved. So so this debugging, it is like detective work. Okay, so you're given some clues and you have to infer the steps that led to the results that you see. So the final output and some other intermediate print statements that you include throughout your program. So they will be like the clues that what is the program state during various stages of the program. Using these clues, you have to basically construct the story of the program and try to track down where things are going awry. So sometimes debugging like can make you, it can be very difficult to deal with. So as a programmer, it is very important to have to develop the patience to actually be able to do debugging. Okay, so many programmers give up that there is some initially, at least there is this tendency that uh, you're sure that you have written the right code and the machine is actually doing something wrong. Especially this is not such a big problem in interpreted languages, but in compiled languages, when you wait for the compilation and the program is not even compiling. Like before compiling, you cannot even run the program, and the program is repeatedly failing in the compilation step. So people tend to blame the machine, that the machine is actually making some mistake. But in 99.999% of the cases, it is you who will be making the mistake. So you have to be patient, and so it is a skill that you will develop with time, when with experience, when you realize uh, that you are actually the one making the mistake. But it is also very rewarding in the sense that when you spend sufficient amount of time and you're able to construct that story, and like a detective you're able to resolve that error, it is a source of a great deal of satisfaction. So that is what debugging is. So this is a few pointers about programming that I wanted to give you. That's all for this video. Thank you.